Mike? Good.
Check.
The power button on it.
Check.
Good. Do y'all walk around, or are you going to stand there? Okay, I'm going to change the page. Go ahead, start. Anytime you're ready.
Hi. All right, good morning, everyone. Thank you for coming to our talk in the 9 in the morning, and I'm early in here. We're talking about InfraOps. The title is inspired from polarization. Essentially, we're going to start introducing ourselves, and then we're going to get into the talk. If the mouse works. Okay. I am Karthik Rangarajan. I am a security engineer at Alpha. We're a financial tech startup based in Silicon Valley. I used to be a co-host on the InfoSec Daily podcast. We ran 839 episodes before we decided to stop. I am currently a co-host on the InfoSec Cloud Problem. We ran about security and generally good security things on the podcast also. I'm passionate about solving problems, especially the security-related ones.
My name is Tobin. I'm currently the infrastructure operations lead at Adapar. I've had over 15 years in like a hybrid security DevOps sysadmin networking roles, and one of my current work perks is trolling Karthik daily. It's a lot of fun. So what are we talking about today? So we're going to first talk about the current landscape of security and DevOps. Our viewpoint, we're a little bit jaded, seeing like what's happening in the industry. Talk about where we see the shortcomings, and then propose our new solution, something that we're doing daily at Adapar that we call InfraOps. We'll talk about the methodology we use, how it works for us, and how we put it in practice. And then Karthik will demo a new tool that we built to automate SSH access for when users need temporary SSH access to various servers. And then hopefully within a few months we'll be open sourcing it soon. So what's the current reality? The current reality is that security is not outside for us. Security is sitting in their own queue, looking out, looking at the developers, looking at DevOps, looking at sysadmins, and being like, hey guys, how about we do this? As far as the development teams goes, it's like, hey guys, let me know what features you're writing, bring me in as soon as possible, can I review it, let me make sure that everything is good to go. For DevOps, if companies are doing more of a DevOps sort of way, it's developers becoming admins, sysadmins becoming developers. People are moving fast, that's kind of scary in security things. People are just pushing to production, let's go. Config management is making lives and configurations easier. And then security teams are, again, still on the outside, being like, hey guys, let's make sure that you're actually hardening your systems and not opening up everything to the world. So everyone has their own priorities, developers, sysadmins, IT, security, business, and security teams are often undermanned and overworked. They can't manage all of these different things and secure all the things. Hopefully tomorrow we'll get to it, maybe not. I mean, we see this daily, there's too many compromises, there's too many risks accepted, and eventually just leads, we'll get to it tomorrow.
This results in a lot of efficiency, and inefficiency is okay, but insecurity also. Security teams, as Tobin said, are often undermanned and overworked, so features get released to production and with glaring bugs in them. Servers are misconfigured or have servers open to the word with I don't know, port 3389 or something. And these mistakes are identified on a daily basis or a weekly basis. They're probably identified on an annual basis, maybe more often if you're lucky, but more often than not, oh hey, let's hire a pen tester, let's run an SS scan, let's make sure this is all validated, and that happens once in a while. And that just leads to the security team just pouring out scotch and just taking shots to make themselves feel better. This leads to the security team getting really nervous. Hey guys, we had this bug in production for so long, we're lucky we're not already found, which leads the security team to going all authoritative and saying, respect my security, you have to follow the following rules if you want to do anything. So the security team starts controlling things, they start saying no, you can't release this feature to production until I finish testing it. You can't have access to the server, which means that people are not as productive as they used to be, they're not moving as fast as they used to, which just results in them being pissed off and not telling the security team anything. So if an overworked security team acts as a blocker, it just makes things less secure. If a security team says no to everything, if we start saying, oh, you can't do this until X, or these are the following checklists you have to take off before you even come to me, stuff like that, they are perceived as a blocker, which means that product teams stop asking security for advice, fearful of a negative answer. DevOps and release teams, who generally move really fast and want to move really fast, perceive the security team as inefficient and as a blocker. As a result, while the security team might think, oh, we have all these processes and controls in place, we're totally secure, it results in a wide open gap that anybody can get through, where in the heads of the security team, there's a small gate that they'll put in place to prevent things from going through, which is generally really bad. Security as an outsider doesn't really work anymore. It used to work at some point, I guess, but it doesn't work, especially in a fast-moving, small, growing company. The most important thing is that security pervades all different areas of the organization. It's not just security as a team sitting by itself trying to reduce risk or make things better. Every team that works within the company needs security help or a platform of security in some way. And being an outsider just makes the security team slower than the rest of the company, which results in archaic processes, and it might actually compromise overall security. It results in a vicious cycle of, hey, we screwed up, so let's institute more processes in place, which makes us screw up more, so let's institute more processes in place. And that's how you get bad security.
So we're introducing our methodology that we're calling InfraOps. And so at the base of this is that security is the default. Security is not an outsider. DevOps is not like a separate thing than SecOps. SecOps is DevOps. And then trying to bring the ideas of DevOps to security in general. Automate everything, verify everything, build, test, repeat, and codify, automate everything. So, like I said, security by default. To create a baseline, be like an open team, helping secure, act as an enabler, not as a blocker, and then just be able to just try to create a culture where security is friendly and approachable. So the first step is to just establish better processes. We don't want to enable onerous processes for people to see security as a blocker. So prepare for failure. Failure is bound to happen. Hopefully they don't cascade or let alone avalanche. Ideally, we remove the human element as much as possible, and make sure that we put in processes and testing and verification in place. So first, all hail our new robot overlords. Make sure that you're testing. Humans make mistakes. Make sure that when you do make a mistake, figure out what you are, how you are making a mistake, and put in various jobs, automated jobs to not make those mistakes again. At Adapar, we use AWS, and so one of the things that we do is we use golden images. And what we do is we take an image of a server, we harden it to the best of our abilities, we make sure patches are all up to date, and we use that as the baseline. So this is the foundation, so build it well. Configuration management. Once you figure out your own wars on which one's best for you, move forward with it and move forward with it everywhere. We're currently using Puppet. We actually use Puppet, Salt, and Ansible for various things. And so one thing that we've seen is that Puppet always wins. If you make a change that's in your configuration management, but you only make it on the server, it's going to get overwritten. And so this is actually a good thing for security as well. So if anyone is making changes, unauthorized changes on your servers, if you have the configuration management set up, it will get overwritten in 20 minutes. Again, bringing DevOps sorts of things, continuous integration, build, test, deploy, repeat. Build, test, deploy, and repeat. I don't know if I've ever built something on the first time and it actually worked. So just keep testing, keep iterating. Bring in like unit testing if you can. We built one tool called Launchpad to help us move forward. It's very basic configuration for actually building the base server. Using the golden image, it automatically logs in, runs the config management for the first time, and we have a secure, up-to-date server in a matter of minutes. And after all that, monitor everything. We use Nagios. Nagios is modded for monitoring. Nagios is extensible. We'll write any plugins that you can think to monitor. We have like app checks to make sure the servers are up to date. We tie into services like PagerDuty to alert us if anything serious is going on. It helps escalate. And then write custom Nagios plugins. AWS has a ton of APIs. They have their own monitoring system. Just write plugins where you can.
So, talking about writing plugins, Python's your friend. It's really easy to use, highly extensible, tons of resources out there to use it, easy to iterate through, even for someone that doesn't really know programming, has only historically written bash scripts or Perl scripts and whatnot. Python's really easy to pick up. There's a ton of books, especially for security. There's Black Hat Python, there's Wild in Python. There's a ton of books about Python. There's a ton of resources on the internet to start picking this up really fast and start iterating through it. And if you have questions, if you have problems that you run into, Stack Overflow, Twitter, a lot of forums will give you the answer almost instantaneously. So what are the things we can automate? From an infrastructure perspective, we want to detect all the services that are running on the internet and what services are exposed on these servers. We want to detect changes to our production environment. This might be we removed a DNS name, we changed the IP, we changed what services are running on here, we changed what machine this is, any of these things. We want to detect where we have SSL enabled, and we want to monitor for configuration of SSL and when the certificate expires, so that when something like Heartbleed happens, we know all the servers that we need to update right away. Stuff like dev server deployments. If you ever work in a company that requires developers to have access to production data for a brief period of time to debug something, you'll probably run into the problem of developers requesting their own server for a long period of time, and that's usually painful because you now have to create the server, maintain the server, and it just becomes painful. SSH user management. Most companies which deal with sensitive data can't really give SSH access to all developers to all servers. This is generally not a thing they do. Some companies do it, and all power to them, but it's not something that we prefer to do. So possibly automate that when users need temporary access, somehow figure out a way to automate this. In terms of applications, at the code level, we want to detect when there's potentially harmful changes released to the code base. This might be changes in authentication, permissions, APIs, whatnot, that might not be checking everything correctly, stuff like that. We want to detect which internal users have access to production data or production instances. These might be users who can log in on your production instance and get access to client data for whatever purposes. It might be for their job, it might be temporary. And then audit all the traffic that you're getting on your API load balancers to make sure that all the sensitive resources that you have is behind secure authentication. So let's start with the infrastructure piece. This is where a lot of the open source tools can help you. Nmap, everyone's here has used Nmap at some point, I'm sure. Let's see, port scan, it's probably the best port scan tool written. Easy to use, has a ton of plugins. Even Python has a plugin for Nmap, has a package for Nmap, as I discovered recently. We also use Gauntlet. Gauntlet is a behavior-driven development framework. Essentially, you provide a set of rules, and you say something to the effect of, run this script and see if the following is true. And you can use Gauntlet within whatever system of tests you have to fail the test automatically if your conditions are not true. Use the library that Qualys has open sourced, the SSL Labs, not the library per se, but the tool SSL Labs to monitor all of your SSL instances. As we mentioned, make sure they're configured correctly, have the right ciphers, have the right certificates, whatnot.
Right, so we mentioned Nmap, some people use it once or twice. What we're doing is we're actually automating this. No one isn't running it by hand anymore. We port scan everything constantly. We get a report as soon as it's done. It's generally at this point daily. So what we do, most of our instances are in AWS. So we use Python, retrieve all the information from our DNS servers, retrieve all of our IPs, whitelist what services ports should be listening depending on what should be exposed, and then scan all the ports all the time. So like I mentioned, in practice, so we use AWS, Python. There's a Python library called Bodo, and this is literally the amount of code that's needed to get all the IPs and DNS names in the AWS. If you see, the actual call is list domains and IPs dot get all IPs and domains from Route 53. It's that one call that gets everything. You can specify your access keys across all of your different logins, whether you want for all of your different AWS logins, loop through, and then pass it to Nmap. To do all this automation, we use Jenkins. Jenkins is traditionally a build tool, but what we found is that it's a great centralized cron runner. So instead of having a random security server running automated scans, not really sure which server it's on, everything runs on Jenkins. It's all very easy to configure. So we configure jobs to run every day, every hour, every minute as it is. For For the scanning one, the port scan in particular, it checks if a scan is running and asks if it is still running. If it's not, it gathers the results and sends us an email. And then we'll update the IPs and domains for the next scan. So part of this in the AWS is that you should validate that all the IPs actually belong to you. We have services, IPs, they're constantly changing. Just saying, you may want to validate before you port scan someone else's server. So again, these go to obtain all the IPs and domains that we currently have, check them against public DNS, check to make sure that the list is correct, and then profit by not accidentally scanning someone else's server or getting a harassing email from security about why we left port 3389 open. I'm like, there's no way we did that. Again, automate everything. Nobody has time to actually run these things manually. You're not going to do it every day. You don't want to do it manually every day. And so this is where Gauntlet comes in. So it's this is the actual code for Gauntlet. It's very it's very straightforward. This is the actual the Gauntlet job that we have for scanning everything. So if you can see at the bottom, that was one of the new guys that started for me. Like Karthik said, bespoke servers can get difficult. We had people who wanted to access their own servers. There's limited resources. Everyone needs a server constantly. Eventually, it made Clint here crumple up and wants to not deal with this anymore. And so he doesn't. And so he created a system he calls Comment. This is the front page of Comment. At the bottom, there are 4 different server choices. You click on the server choice for memory, disk usage. It says OK, and then you get an email about 10 to 15 minutes later that your server is ready to go. You can deploy whatever code you want to it. You have SSH access to it. You specify at the bottom how long you want access. As soon as it expires, the resources go away.
He was supposed to speak about this, but he doesn't want to deal with SSL ever again. And I don't really blame him. So, SSL checks. We've had a few bugs in SSL recently, right? Heartbleed and Poodle and all the good stuff. So it's good to know what servers are running SSL, what versions they are, what ciphers they have on, what certificates are, when the certificates expire, what certificates they have, what not. So our automated nut scan actually gives us a good idea of what ports are open to the internet and what public-facing servers have certificates installed. We also run an internal nut scan to get all the stuff internal servers with SSL enabled. So we have a script that goes through and checks certificate validity, sends us a report of all the certificates that are expiring in the next 30 days or the next 60 days, so that we can use this report and profit by not bringing down production for 2 hours, which I was never responsible for, ever. We also use something called RippleGuard. It's a tool that I presented on last DerbyCon. It's a tool that Fuzzy wrote to automate a lot of their code review tasks. We have about 80 to 90 developers, about 60 to 70 commits per day across our main repositories. It's really hard to keep track of all of this code. It's really hard to keep track of the hundreds of pull requests that come through every other week. So for that purpose, we extended the tool that Rosie wrote, and we use it to track potentially harmful changes. So changes to permissions, changes to authentication, stuff like that, We can go through it, mark it as a false positive, proof positive, whatnot. The goal is that we use this, we write more rules, extend it, and we make this also a Jenkins job so that every time the unit tests run, the integration tests run, this also runs and sends us an email in case there is a potentially harmful change, or even better, comments on the pull request. We use GitHub, so it comments on the pull request stating that security needs to review this. We use an API. We have a REST API that of JavaScript front-end accesses, and some of these are internal APIs, some of these are external APIs. Some APIs need auth, some APIs do IP filtering, but all of them exist on production. And even minor changes in the filter steps can result in major problems. We use Jersey filters to make sure that everything goes through the correct IP filter, goes through the correct authentication filter, and whatnot. And if people modify something, put those filters in the wrong order, we now have what we call for internal only routes accessible to the internet. So what we do to fix this or to monitor for this is we use our logs. All of our API logs goes to syslog. We get the list from syslog, feed this list to the script that makes requests to these resources, and we ensure that the response is what we expect it to be. So again, we use Conflict for this, and the output, the Conflict script, all it's doing is calling a Python script and just checking that the number of routes that failed is 0. This helps in automatically failing the Jenkins job and sending us a report if it fails. Automated alerting. So again, it's a great idea to aggregate all your logs in a queryable consumable format. There's open source ways to do this. You can use Elasticsearch, Logstash, Kibana. Might make you a little miserable, but it works. You can also use Graylog, which I've heard is really good. There are commercial tools as well, even though you might have to shell out some money for it. There's Splunk, we use Sumo Logic, and it's really good. It helps you keep track of everything that's happening on your environment, put it all together, make sense of it. So it's a good idea to listen to the story that your logs tell you. It helps you detect things like brute force attacks and unauthorized SSH access, stuff like that. And a good way to do this is to create dashboards. When you create these dashboards, you have graphs, and when you see an inordinate spike in the graph, you know it's time to investigate it. You can use dumb mechanisms, like, as I said, just, oh, this is spiking, or you can use really intelligent ways to do it by using stuff like Pandas, which is a Python data analysis library to look for outliers and send an email, or perhaps do more analysis if there is such an outlier. We have, as I said, we have a product that's used by our customers, and some of our internal users have access to production instances. Most of them, it's to do their jobs. Some of them have access temporarily to help fulfill a requirement, help the customer achieve a goal that our regular employees can't really help them with, stuff like that. As a result, it's a good idea to access this access constantly and ensure that there isn't random people accessing, random internal people accessing your production instance. So you ensure that there's always a white list of people. One good way to do this is to tie it back to your company directory and see what job roles need to have automatic access. And then use applications APIs or the databases to get a list of all employees who have access, use the source of truth to compare it against it, and send an alert to all users who shouldn't have access based on their roles. And we use a tool called Flylist that we wrote for this, which essentially does these things. Obviously redacted all the names and emails and whatnot, but essentially all this is saying is these are all the people that have access to client firms. These are the exceptions to the rule, because there might be a bot, they might have access for whatever reason, but we get an alert every day. It automatically alerts the people who have client access. It tells them, do you still need access? If you do, provide us a reason why. If you don't, your access is getting nuked in the next 24 hours. So we spoke about SSH access control briefly. Everyone who's had Linux servers has dealt with people wanting SSH access to everything. Every bug is filed on production. As a result, the bugs can only be resolved using production access. So people want access to production servers every day, all the time, which is not the best idea. Usually, when developers or QA or whoever wants access, people DevOps grants access by adding their public key to Puppet or similar configuration management system. Forget to remove the user from Puppet. A few months later, you're just randomly auditing the server, and you find out that the user, the employee that left 3 months ago, still has access to the server, which leads to much sadness, very insecurity. So, enter Doorman, not this Doorman, which is our automated access control system. Users request access via this tool. The tool looks up the user's manager using a directory structure. This can be LDAP, AD, any other directory structure that you come up with. Access is granted, the user gets created. When the user's time expires, this might be an hour, this might be a day, this might be 30 days, access gets revoked. We don't have to worry about it ever again. It's awesome, automates everything. It's awesome. Anyway, so we wrote this tool internally at Adapar initially using Node.js. It tied into a lot of our internal services. I decided to rewrite it using Python and InfraOps. It's relatively really extensible. You don't have to tie it to LDAP, you don't have to tie it to AD, you can choose your own authenticators. So if you have a single sign-on using something like OneLogin or Okta, you can totally use that too. It's really easy to set it up. Code for it, stuff like that. Uses class, attempts to follow the best practices for writing a Python backend. And it uses InfraJS, which is a highly extensible MEC framework written in JavaScript. And our company contributes actively to InfraJS, has a lot of InfraJS libraries, and I took a help from developers such as Dylan to actually help me get up to speed and write this. So, enough talk. Let's see if my demo actually works. I forgot to create a demo box this morning, so let's find out. Okay, people still good? Cool. Alright, so oh, that still works. Cool. So now the tool's pretty simple. We have connected to our LDAP directly, so I'm just going to log in using my LDAP credentials. So this is our automated control system. It says, oh, you want to submit an SSH access request. The first thing you should do is add a key. So let's go ahead and add a key. I'm going to call it DerbyCon key. And cool. Great, so now we're on our key, so I'm going to go request, but I see that there are no servers, there are no existing servers, there are no whatever servers. So right now the way we solve this problem is we have a static list of servers that we provide access to. Instead, what I decided to do is create an automated way to do this too. So, so the way it works is that each server will have a script that it runs to register itself. To register itself, gets a token, makes all the requests it needs. So let's say this is a production server. I'm going to run run that. Cool. So it sent a list of servers. So now if I look here, look at what servers. Oh, look, already found out my local showed up. Let's try another server. Let's try, say, cool. Okay, so let's refresh this again. Cool. Cool, so now we have two servers that we can access. So let's say I want access to DerbyCon. I request access for 24 hours. Actually, it's 1 hour. Set my key. Make a request. Eventually, hopefully, it'll make a request. There, so new request created. If this wasn't the production server, I would have automatically gotten access. Now my team lead, which is me, hopefully, yeah, so I get to approve it. Do I want to approve this request? Absolutely. Cool, so request has been approved. So now, because I haven't actually automated this, I'll have to run the script again. Let's do that. So cool. I'll try logging in to that server. I have access. Awesome. So I didn't have access before. After requesting access, I have access. Let's try to see if I have access to the other server. Turns out I don't. So let me request access to that too. So 1 hour. Great. Get us the email. Approve. Go. Do this. Great. So let me try doing the same thing again. Great. So I have access to both these servers. So now that we don't want to wait for 1 hour for my access to expire, let's see how that will work for my access to expire. So I'm going to manually expire my access. Expired access to both servers. So now, the way this really works is that it's supposed to send a heartbeat every 5 minutes to tell the doorman server that it's alive, that it can accept requests, that it has added users, deleted users. So now, if I send another heartbeat to it, doorman is going to send it a list of all the users it needs to add, which is what I did earlier, and all the users it needs to remove. And so now we just removed the server, so let's try accessing it again. And ideally, I don't have currently CMO doesn't work. Great, I don't have access. Let's do the same thing here. That's not me. Where do I find it? There. I'm gonna send a heartbeat. Expire my access to it? Yep, definitely not expire my access to it. But yeah, you get the gist of it. It automatically sends a heartbeat, registers itself, gets a token that it can talk to the server with, and it gets a list of new users to add, that's a list of new users to remove, whatnot. So the users are expired, or the user access is expired, and it automatically removes everything. So great, no more writing about SSH access rows, no more writing about, hey, let's make sure we remove them from Puppet, all of that stuff. We haven't yet built this into the tool, but in the tool that we currently use, you can also get a list of all the users that have access to all the servers. And then you make sure that you have a white list of users that have permanent access to production servers, and everyone else just gets removed constantly, which works great. So that's the demo. And before we get into the questions, we are hiring at DataPark. We are hiring for a DevOps engineer, a security engineer, and a network sysadmin, all based in Mountain View, California. So if you're interested, please go to adapark.com/careers, come talk to us, come chat with us, any of this works. Happy to provide more information, any details if you would like. We're a team of builders, we're trying to do awesome things, fix finance, fix security, fix everything. Cool, that's all we have for you. I'm Karthik, go by Rangarajan on Twitter, down Tobin. Dan24 on Twitter. Happy to answer any questions you might have. Yes.
You had any developers who had a problem kind of explaining SSH how to use that keys part of it?
The question was how many developers have we had problems with explaining SSH and explaining keys? I don't think we've had problems with developers per se, or developers are pretty smart about it. We've had problems with certain non-technical people who also need SSH access for some reasons, and then we have to make sure that, hey, this is how SSH works, this is what you do, don't give me your private key, because I really don't want your private key. Cool. Anybody else? Yes, sir.
Acceptance in the semi-developer community, the DBAs, the data analysts, tend to always think that they should have access. Is that an issue?
That's a great question. So the question was, in the semi-developer community, in the community of DBAs, data analysts, who think they have access to data. At this point, we haven't yet built that, but it's definitely something I want to build. It's something we're working on, is automating access to databases also. So if somebody wants access to MySQL, whatever, they go through the same mechanisms, request access, expire access, whatnot, so that it's trackable, auditable, versus I'm going to have access to all data all the time. Cool. Any other questions? Awesome. Thank you so much for showing up, guys.